Can you close that door, please? Write down this. This is the book definition of a function, and then we'll talk to you about it. It's a mathematical rule. Just put in math. A math rule that identifies a relationship between numbers. Wow, that's fun. That identifies a relationship. You guys are good with relationships, right? Relationship between two sets of numbers. And basically, there's a whole bunch of different ways to think about this. But basically, I think we've talked about this maybe before. You have what we call, the book makes this little thing I like to draw because I just like to draw. A function machine. Looks a little Willy Wonka-ish in the end here. Okay, where you have this right here, which is an input number. You put something into it. Okay, there is a rule inside here that changes that number, and it spits out this little thing right here, which is an output number. Now, an example of that would be this. If you are talking about the perimeter of a square, there's a formula that says the perimeter of a square is 4 times whatever each side is. That's our kind of our rule. Well, the question is this. Here's sometimes where we have some trouble. Which one of these, is this the input number or is this the input number? Do I write the perimeter in usually and try to figure out the side of the square, or do I put what the side of the square is and get what the perimeter is? Which is usually the way we do that. Brianna Massey?
The side first.
Right. So S is the input number. A lot of times we use X's and Y's, and P is the output number. In other words, I input how long the side is. The rule is you take 4 times that. You take 4 times it, and what gets output is the perimeter of the square. Okay. For example, if the side of a square is just 1 inch, my little square is a 1 by 1 by 1 by 1 square. I put 1 into my little input machine. Let me make 1 so that it'll work. I put 1 in. Watch the magic going of the board here. Sorry. I put 1 in. 4 times 1 changes that 1 to a 4. And that 4 gets spit out as my output number. So that is what they want you to call function. It's really, it's kind of what the word means. What is the function of this or that? Now, with that being said, I have to make sure. We have what are called linear functions and not linear functions. Linear functions. And a linear function would be a function that when graphed, comma, you get a line. Which most of you probably figure out because most of the times. And what is meant by that is this. Let's say I make a table of a whole bunch of values of this. Remember I put 1 in and I got 4, right? If I put 0 in, if a side length is 0, what's its perimeter? What's that? What's 4 times 0? 0. If the side length is 2, I stick it in my machine, 4 times 2 is 8. If the side length is 3, I stick it in my little machine there, 4 times 3 is 12, right? If I graph these numbers, do I hear from over here? Good. If I graph these numbers, do I get a straight line? Well, 1, 4, here's 1, 1, 2, 3, 4, 0, 0, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, 3, 12 or whatever. I'm going to get something that does this, and I do get a nice straight line when I graph it, so that is what is called a linear function. Which would lead you to ask, would there be something that's not a linear function? I am so glad you asked. Let's look at this. What if we were doing the area of a square? The area of a square, what is the formula for area of a square? Keith Stewart.
Area equals,
Oh, that's rectangle. I want a square.
area equals side.
Okay, area equals side times side, right? Or we could say area equals side squared, right? So let's pretend, let's make a table. I won't draw the whole machine again. Oops. My input number is still the S's. My output number would be the area, X and Y. Alright, let's do the same thing. If I put 0 in for my side length of a square, what's the area of the square? 0 times 0 is? If I put 1 in, 1 times 1 is? If I put 2 in, 2 times 2 is? If I put 3 in, 3 times 3 is? If I would happen to put 4 in, 4 times 4 is? Okay, now, let's actually graph this. Okay, here is point 0, 0. 0, comma 0 is right here. 1, comma 1, 1, comma 1 is right there. 2, comma 4, 2, 1, 2, 3, 4. 3, comma 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4, 16, that's going to be way up here. 9, 10, 11, 12, 13, 14, 15, 16. This, if you were to put this into some sort of calculator, gives you something that looks like this. And that is not a line. That's got a nice little curve to it. It would be non-linear. It would be non-linear because you get some sort of a sloping sort of arc sort of thing there. And they have a picture of that thing. So they are going to ask you to do this, children. Here's an example here. Graph the function. And here is the function. The function is going to be y equals 1/2 x minus 2. 1/2 x minus 2. In order to do this, boys and girls and ladies and gentlemen of all ages, if they tell you to graph the function, the first step is you must make a table. This isn't your dining room table, nor is this the table that you find in most living rooms. That is this. Nice little X and Y table. Step number 2, children. Now here's where a lot of people get confused. You, just like I did with the square and the perimeter and all that stuff, you, Y-O-U, get to pick the input, which is also the x numbers. So just randomly, willy/nilly, out of the air, you get to pick whatever you want to put in for x. Now, I wouldn't get all goofy because you're not going to be able to graph goofy numbers. I would certainly always pick 0 because that's an easy number to work with. Okay, now then in this case here, since I know my x is going to get multiplied by a half, I would pick numbers that are easily you can take half of. I wouldn't pick 5 because I can do 5, but half of 5 is 2 1/2, and then I have to work with fractions. So I would pick even numbers just because I get the choice to. I would pick 4. I can do half of 4, that's not so bad. I might pick 6, I can do half of 6, that's not so bad either. I might pick 8, I can do half of 8, that's pretty easy. So there I picked my input numbers. Then you have to, step number 3, you have to solve for the output numbers, or the y numbers. These should not be that difficult. If I put 0 in for x, what's 1/2 times 0? Minus 2, what's 0 minus 2? Minus 2. If I put 4 in for x, what's half of 4? 2. And 2 minus 2 is? Whoever said 4 back there. If I do half of 6, what's half of 6? 3. What's 3 minus 2? If I put 8 in for x, what's half of 8? 4 minus 2 is 2. Now these, children, are plotted points. You are going to take those values and you are going to plot on a coordinate system. And you will not make the teacher very happy if you just draw your coordinate system all willy/nilly again. You've got squares on your homework paper, you're going to use those to find x and y axes and draw all that. Me, I don't have them here, I could get them, but I'm good enough that I don't need to. You are not good enough that you need to. And you're going to plot these points, they will fall into a line and you'll draw that line. Watch. 0, -2. 0, -2. 4, 0. 1, 2, 3, 4, 0. 6, 1. 5, 6, 1. See that line that's coming up there? 8, 2. Then you need to take your straight edge / ruler and draw this line all the way through the graph. That is the graph of that function. Input numbers, output numbers. What does this line mean, Elijah Fisher?
It's linear.
No, what does it mean? I know it's linear. I'm not asking for the characteristics of it. Children, this line is, Emily? It is a function. But that's not, what does this line mean? This line is every possible answer you can get for this function. This line represents all the input numbers and output numbers you could ever get. For example, if I were to put -1, if I were to put -1 in for x, where this line crosses that -1, which is right here, that's what I would get for y. I'm going to guess it's probably -1, -2 1/2 would be my x. Or if I put -2 in for x, wherever that crosses this line right here is what my answer for y would be, which is probably -3. Should I try it? Oh look, if I put -2 in for x, what's half of -2? -1. -1 and -2 is -3. This line stands for every possible answer you could get. Okay, that's why there's arrows on it. It goes forever that way, it goes forever this way. We don't have time to draw our graph the entire size of the entire universe because that would take you forever. You wouldn't want to do it, but this line stands for everything you want to know. Right, Em? Just don't go behind my desk. You can go as far as you up to that line right there because it's kind of like my personal space. I kind of like it back there. I should have walls built there with a window. That would be better.
Yeah.
Maybe a Trump sponsor it.
You got that? Let me give you one to do here. Let me find one here for you. Problem number, let me find it here. Here it is. Y equals 1/2 x plus 1. You do this one for me right now. Y equals 1/2 x plus 1. Graph this function. Which means you're going to have to make a table. You're going to have to plot, pick your own, just out of willy-nilly, out of the air, your x values. Put those x values in and find the output/y values. Plot those points and graph. Feel free to start now, Mitch. Feel free. Again, you get to pick nice numbers again, since this is the fraction 1/2. I pick even numbers. You don't really want. You can deal with fractions if you like, but I would pick even numbers so they go away. You could put negative numbers in there too if you like working with negative integers, but again, I don't know if I would if I were you. This will be a great chance to see your graphing abilities. Somebody has learned how to draw stuff, I appreciate that. Somebody who never gets this not see if you get the same on the the line needs to go all the way through both sides of the fair graph. Give me another 30 seconds or less. By the way, this should be a straight line. If it isn't, you're not real good at drawing dots. Which will be solved on your homework paper because they're all squares there. And by the way, you need to pick at least 3. You need to at least pick at least 3 x values. Don't pick more, that's fine. But you can only assure that you did it right if you pick 3, because you can always get a straight line between 2 points, but you don't always get a straight line between 3 points. Okay. Danny Baumgartner, what x values did you pick? Give me your x values. 0 was my favorite, yep. 2, 4, 6, that's not bad choices. If I put 0 in for x, 1/2 times 0 is 0, 0 plus 1 is 1, I get 1 for y. If I put 2 in for x, half of 2 is 1, 1 plus 1 is 2. If I put 4 in for x, half of 4 is 2, 2 plus 1 is 3. If I put 6 in for that, half of 6 is 3, 3 plus 1 is 4. Doesn't matter what numbers you put, you're going to get the same graph. Here is my x and y axis. 0, 1, here's 0, 1. 2, 2, 1, 2, 1, 2. 4, 3, 2, 3, 4, 1, 2, 3. And 6, 4, 4, 5, 6, 1, 2, 3, 4. And you should have your line, I don't know why I did that, go straight through there like that. Your line should be that same slope and look very much like that. If it didn't, you did something wrong and maybe your lines are not consistent with that. All of your points should line up in a row. You should be doing this on, when you do on your test, you should do this with a straight edge. There should be no question as to whether they are straight lines. Anybody's not worked out like that and don't know why. You know, if you get a point out here somewhere, then you did something wrong, because something isn't right. Because these will all become straight lines and linear for the most part. You guys